In the practice questions and to show boundedness generally, we make use of Supremum norm a lot. So I'm just making this video to explain what Supremum norm is and how it works, how it acts using this simple example. So I'm taking a function, I've defined the function to be f of x equal to 2x squared. Now on the interval 1 to 3, and this is a closed interval. Let's note that as well. Now we want to define how the supremum norm works rather. So this is the definition of supremum norm. So norm of x is equal to the supremum of the absolute value of x on this interval, for x being in this interval. I don't know if that makes sense. So we are trying to find the highest value that x can be, the highest possible value that x can be. That's what the supremum is. So, and we have defined that the norm is equal to that supremum. That's why we are calling it a supremum norm, because we've equipped the norm with supremum, or if that makes sense. So now I have absolute value of x here, and I have the interval. To get the supremum, this is very, very straightforward. I just have to look for the highest possible value that x can be in this interval. And because this is a closed interval, the highest value here is 3, because x can be 3 since 3 is in this interval, right? So that's why we have 3 to be our answer here. Now moving on to something else, which is the norm of f. We've also defined that to be the supremum of the absolute value of this function here. So we have moved from x to f of x now. So we're going to be dealing with this function since we've defined f of x to be this. So now that is going to be the supremum of this here, that is 2x squared. So how do we calculate the supremum of this? It's just imputing the highest possible value of x in the function. So since we have x to still be in the interval 1 to 3, and it's a closed interval, so 3 is among, so the highest possible value of x here, which is supremum of x, is going to be 3. So I'm now going to include that 3 in the function. So wherever I see x, I'm going to put 3, and when I put that in, I get my norm of f to be 18. Now, where I want us to, what we need to note exactly in all of this example is here. Let me draw a line here. So I want to tell you how we came about this last line, because this is what we'll be using mostly in our questions. Now, this is the supremum of this function, right? The norm is the supremum of the function. Now, if I pick any arbitrary function, this is representing an arbitrary function now. So now, an arbitrary function is that I'm just picking any random x, but the x just has to be within this interval. I'm not setting a particular value for the x, right? I don't know what particular value for the x is. I'm just picking any random f of x. Now, that particular f of x would always be less or equal to the supremum, right? Which is the norm. That's why I have that f, the absolute value of f of x, is always less or equal to the norm of f. Why is that true? That's because the highest value of f of x that we can have is the supremum, but we can have other values that can be less than it. So if I'm just picking at random an f of x, that f of x can either be the supremum or lower than the supremum. So for example, in this interval, I've picked my x to be 2 here. Since my interval is between 1 and 3, 2 is within that interval. So I've picked a random x. Now the answer that I got while putting x to be 2 is 8, and 8 is less than 18. If I picked x to be 2.5, I'm going to get an answer that's going to be less than 18. If I pick x to be 2.9, I'm going to get an answer that's going to be less than 18. Every answer I'm going to get is going to be either less than 18, or when I pick the highest value of x, which is 3, I'm going to get equal to 18. So this can be either less or equal to the norm, since we have defined the norm to be the supremum, which also means that the norm is always greater than or equal to the absolute value of f of x. So yeah, this here is what we need exactly.